The ratio test is a test for convergence or divergence. So if you have an infinite series where n is going from 1 to infinity of a sub n, and it's a series of non-zero terms, the series of a sub n will converge if the limit as n approaches infinity of the ratio, and it's the ratio test, of a sub n plus 1 over a sub n, absolute value is less than 1. Now if you think about it, the n plus 1th term is the next term. So what you're saying here is that this term has to be less than this term for this to be less than 1. Now the absolute value gets rid of any alternating series or anything like that. So you have a decreasing series, absolutely. If this, well, the series will diverge if that limit is greater than 1. And unfortunately, the test is inconclusive if the limit equals 1. So this series actually, this test works really well when you have different kinds of series that have things that look exponential, like 2 to the n here, or factorials like an n factorial. So if you see those, or combinations of them, if it was just 2 to the n, it'd be geometric, but if you have it in combination with something else, you might try the ratio test. So for the ratio test, and we're going to test this one, what we're going to do is actually take the limit, do it down here, the limit as n approaches infinity, and I'm going to write the n plus 1th term. So this will be 2 to the n plus 1 over n plus 1 factorial divided by the nth term, and that's 2 to the n over, just n factorial, and we're doing the absolute value. Now for this one, since n is going from 1 to infinity, everything is positive, so we don't really need the absolute value, but you could. So to simplify this a little bit, when we divide fractions, we'll multiply by the reciprocal of the denominator. So this is equal to the limit as n approaches infinity, and I'm not going to have the absolute value because I don't need it for this one. So it's 2 to the n plus 1 over n plus 1 factorial times, and then I'm going to multiply by the reciprocal of this, so n factorial over 2 to the n. And I'm trying to figure out what this limit is. Is it less than 1? Is it more than 1? So the 2 to the n plus 1 over 2 to the n is very easy to simplify. I have one more 2 in the numerator than I do in the denominator. So these two will just reduce down to a 2 in the numerator. And you can think of it with properties of exponents. When you have two things divided with the same base, you subtract the exponents. So n plus 1 minus n is just 1. So we are left with just a 2. So I'm going to say that this is the limit as n approaches infinity, and we have a 2 in the numerator. Now the factorials. To simplify the factorials, if you're not used to doing this, it might be helpful to write out a few terms. N factorial would be n times the next number less than n by 1, so times n minus 1, times the next number less than n minus 1 would be n minus 2, etc. Well, n plus 1 factorial will be in the bottom, in the denominator, and it's n plus 1. Then the next number less than n plus 1 is just n. The next number less than that is n minus 1. The next number less than this one is n minus 2, etc. Well, you can see that they will all cancel out except for the n plus 1 in the denominator. So I'm going to put n plus 1 in my denominator. Now when I actually take this limit, the limit as n approaches infinity of 2 over n plus 1, I would evaluate at infinity. Infinity plus 1 is just infinity. 2 divided by infinity, or something really, really large, is equal to 0. So what I would say is that this is clearly less than 1. So our series diverges, less than 1, it converges by the ratio test. And what you want to include is what's important about this limit. And in this case, it's less than 1. It is either going to be less than 1 or greater than 1, because if it's equal to 1, you have to go find another test. So this is what's actually important for this test. What is your limit?